Everyone, my name is Sunny Hirapura, and now we are going to present the bridges and culvert of South Texas. Uh, and there are 14 counties in the South Texas, and our team is Brown team. And first of all, we need to show we collect the data from that side. Here you can see here that side, and we first of all our characteristic of beach and culverts we use. There are 14 characters of bridge and culverts we use here. County code, structure number, features intersect, facility carrier. We use that all the characteristics from the BGs and culvert files, and we have Excel file, so it's a CSV file. So we're going to use that file, and now we are importing the necessary libraries. First of all, we import the pandas, SQLite, OS for the path defining, and GeoPandas and Matplotlib for the plotting the graph, and Shapley geometry for the converting the geometry geometry condition. And now we import the CSV file of bridges and culverts. Here you can see that we define the path. You can see here we define the path for the our CSV file, and after that you can run the file, or you can run the code of CSV file, and we read the we can read the CSV file. Here there are main our file. It's a national bridge inventory file. It's our main file, so we can first of all we read that file, and after that we filtering the data and taking and extract the only Texas state. And at that file the Texas state code is 48, so we can extract the only uh, Texas data. So that's why we extract and filter out and refine the data of 48. And after that we extract the bridge and culvert data. Here you can see here it's for bridge and it's for culvert. We separate out two different Excel file for our bridge and culvert. And after that we convert the state file to Texas, and bridge and culvert file to the CSV file. State file, bridge file, and culvert file. Here that three files. And after that we extract our necessary column, like we have 14 or 15 necessary column for the making the relational database of the bridges. That's why we extract the 14 columns for using the ilog command. Here you can see here it's ilog. We use the ilog command, and we also set the index as a county code 003. We can make it for the index. And after that we also make it CSV file for our references. That's why we can show the what data is there. And after two we make the data2 object. It's for culvert. And after you can run it, you can see here there are 14 columns. We successfully extract the all 14 columns and rows by the Texas and by, by the county code. And after that we make the other CSV file by manually, because there are so many properties in the each column. You can see here there are a maintenance responsibility. So yeah, here you can see here there are each row shows the some different number. Each number shows the some different description. That's why we make the another CSV file. You can see here 3 and 3 6. We make the 6 CSV file for our database. So we create after that we create the database for the SQLite, because we will going to make the relational database, so we need to SQLite. That's why we create the database of SQL, and after that we connecting all the CSV with new created database. So we put all the CSV file in one database. That's why we run that command, file name to SQL, the file name to SQL. That's why we after that we will run that. So we will run query after the connecting all the database in one database. So that's why, and the remaining part will be covering my colleagues.
One. Now I will be continuing the code for making relational database. In relational database, there is a primary key and foreign key, which connects the two databases, so that we don't have to create a large flat, um, flat data database. So that's why here you can see in this is our breeze. This is a this is our breeze data where we have like structure evaluation. There are certain values like 777, and these are not unique. So this is a this can be a foreign key for any other database which consists primary key with all of these values as unique and has certain description for it, because you can understand what is 7 here, right? So we have that in another table as we get like we brought this another CSV file which have this appraisal rating. So in there is this structure evaluation as primary key. So as we have connected all the CSV files with SQL, and after that we do concommit so that the tables and the database are connected, and after that we start by running cursor. After running cursor, we can create other tables or run queries. So first of all, here we are creating a main table which connects the breeze table with a special table so that we can connect datas with the county name. Here you can see we have joined this by um, using a special join. By doing this, we have created a main table and joined them. By joining this by using in special county code 3 is a primary key, and in breeze it's a foreign key. So by joining them, we can connect those both tables and get whatever column we want and create another table main. So I created this so that we can get data for only counties we want. That is the 14 counties, Southeast Texas. So next up, by taking this table, we selected this structure number, longitude, latitude, and gave where we took the datas where the structure condition were 7. So these are our datas. Next we for obtaining the geometry of the breeze plot so that we can plot a map. We first of all did this code geometry equals to point xy for so that we can change this longitude latitude to um, points, and um, and after that uh, uh, by using main table only, we found out the maximum ADT, maximum average daily traffic consisting breeze, so which is this 1210200, this one, and so it is in Harris. You can see here in the output. This is our this is our query. So next we join the main table that we created with a structure type, so that we can um, obtain the description of what those 6 7 are there in structure type. Here we can see we connected structure number, county name, description with inner joining with the structure type. So in structure type, the structure kind is main. Since I already told you, the number have to be unique in this one, so it's unique in this. And in main, it's not unique. They have lots of same number repeating. So that's in main it's foreign key. So after that we run the query so that we can get the structure numbers, count of structure numbers which are made of wood or timber. So it's 84. Next we run the query to see the number of bridges that are made of various metal in 14 counties. So you can see that in Jasper, if the structure is made of aluminium, there are only two numbers. In Walker, if it is made from concrete, there are like 400, 947, and so on. Next we created table by using breeze with a breeze with special, so that we can get the structure length for breeze length for all of the breezes present in different counties. This we are going to use it to plot the bar graph. So next we group the county name and county name group the structure numbers, structure length with the structure length with it according to county number by summing one structure length with other, so that we can get the total running length. It consists in one county. So these are our total sum in chambers. The total running length of bridge is like 11841.9 and so on. After that, we plotted the bar graph and sort the total running length. And here we can see the Harris have the maximum running length, and it consists more number of bridges. So next we connected a culvert with a spatial in the similar manner, and then we joined the new main to table with culvert condition, so that we can run query about query uh, query where uh, where the culvert is in excellent condition, having no deficiencies. So we can see that there is only one culvert that have no deficiencies. While next we were training for worse condition. For worse condition, you can see there is none that have worse condition. So after that, we ran the query to find out what kind of condition most of the culvert are in. So here we can see 1016. This is the maximum culvert that are in uh, maximum culverts. This condition applies for maximum culverts, which have like they have like shrinkage cracks, light scaling, insignificant spalling, um, and you can see the paragraph to see it. So after that, we created another table uh, um, by by using maintenance and yeah, so that we can see the how many culverts are maintained by state highway agency in those 14 counties, and the number is 916. So after that we have we are starting to plot maps, and that will be covered by Rahul. Thank you.
Hello everyone, I'm continuing from the map part. We are taking for plotting our data onto the map of the county shapes. We need a boundary shape file. So we got the boundary shape file from the online. So I've read that county shape into my county one and I plotted it. This is, yeah, you can see this Texas boundary shape file. And from this I need only our 14 counties map. So I'm doing removing 14 counties, extracting 14 counties, and the string contains bmap 1. So, and again for these 14 counties, sorry, my bad. For these 14 counties, I have done a for loop for having the 14 counties data without losing it. You can append it from one after another. So Then we concatted it, and the object of our shapefile looks like this. Then if you plot it, you can see our shape county has minimized to our 14 counties area. Now, now let's now let's convert this shape file into geodata frame. Like, you can use this code, and from this code I just read into another GDF, so it's easy to plot. Now I'm plotting the superstructure condition, which I have defined earlier with GDF2 in the SQL part. So by this we can plot GDF plot. GDF is our geo county, just our boundary shape file. We will plot the boundary shape file, and on the above of it we will give our GD to where our super condition structure is good. With that SQL we can give this SQL here. Yeah. So these are our bridges in Southeast Texas, which are in good condition. So by this you can plot many plots with this. I mean, if you can change GDF to, if in our data we have super condition and structure kind, by whatever description you can give, whatever SQL command you can give, you can save it to a GTF data frame, and you can read it as a geopanel data frame. Then you can plot it on both by converting the last polygon points to geometry points and running it. Here is our geo county, which here it is L, and my length L data frame is data frame structure longitude and latitude from the super condition where 7, our super condition variable 7 is for the good variable. So wherever the are good, we are removing that as an L, and we are converting it to geo county and taking that XY latitude of that point to polygon for plotting on the plot. And last, we can plot our points on this empty shapefile by using this. Play with GeoPandas and Geo these plots and our CSV files, data frames. You can play all with this, and you can show each county's related data, and you can compare it with any you like. Thank you.